Hi guys, thanks Brian. There we go. Yeah, so conferences like these are the very best when a senior engineer who's had 10 years of experience in an undocumented field is able to sort of take the hour and talk about the things they've learned that have been hard. This is definitely not that talk. Instead, this is me, a sort of crappy web developer with no experience in linguistics or anything similar, have an unreasonable level of success with this library I built, a sort of side project. It's called NLP Compromise. And the idea is that it's a natural language toolkit, sort of similar to what's out there already, except it's one JavaScript file at the end of the day. You can npm install it, and it's around the same size as jQuery compressed. It's not the most accurate natural language processing engine, that's for sure, but it's good enough, hence the name NLP Compromise. And the surprising level of success I've had with this thing has made me think that I've actually stumbled into a hole where this software has not been written yet, and it should. So this is the most upvoted comment ever on TechCrunch. It's this guy, 5 years ago, when Uber was just starting, and he said, I have 30 years experience in car sharing industry, and here are the reasons. He gives these great arguments why Uber is not going to work. The takeaway from this is that sometimes being a non-expert is actually a good thing, right? Because you run straight into the problems that other people knew you were going to run straight into, and sometimes you're able to pull them off. So I'll talk briefly about how I get into this stuff, how I fell down the rabbit hole of natural language processing. I was working at a startup. We were 2 weeks away from launching. It's a bit of a joke because every startup is 2 weeks from launching, but we were. And we were ready for user testing. And our main call to action was something like this, where there's a search box, and we're expecting the users to type in things. I was the search guy. I imported all the Wikipedia articles into Elasticsearch, and we were expecting things like this, where people would type in something we knew, but they would have misspellings and stuff like this. What happened when we had users come in, the first person typed in this, London in the rain. And we don't have that. That's not a Wikipedia article. The next person typed in that new gold iPhone. And we didn't have that either. So it was brutal. And it was all my fault. And my boss called me into his office that evening. I had a suspicion I may get fired, but he's a very nice guy. He said, Spencer, we have this term, London in the rain. We don't have the full match, but we do have the word London. So why don't we just chop up each word and search for them as a fallback when we don't have the full thing? Now, I knew that some of our terms are two words, or 3 words, like London, Ontario in the rain, or Paris Hilton in the rain, so forth. So it's not quite that easy. I knew what we had to do was an n-gram. If you took Computer Science 101, it's just a substring or a subsequence. But it's you grab all the two-word sequences or the 3-word sequences and stuff like that. The problem is that we were running this in keystrokes. So even if somebody types in 4 words, that was 10 HTTP requests per keystroke. And of course, they could do a lot more, which threatens to certainly crash our search API, but maybe even their browser if it was too much. So I knew this was a problem, and this wasn't going to work. And we had 2 weeks to get it going. So I did, I think, what anybody would have done in my situation, or at least sort of the clumsy strategy. I made a list of stop words, so the and in. These are really frequent words, and they're words that we definitely know we don't want to search for, so we ignore them. The second thing I did is these, in the second column, terms that started with the word in, or ended with the word in or of. Words like this are very unlikely to be something we're looking for. An exception would be of mice and men, but you can imagine there were very few of them. So what I did is I Googled what is in and of, what is the part of speech. There exists a branch of linguistics, I knew that, at least, and in and of are called prepositions, and the other ones are by and for and things like this. So by filtering out words that ended in a preposition, we were able to get half of them gone. And the last column, of course, would be the rain, when we're already searching for rain. The Rain is a pop album or from Korea or something, but The rain is redundant when you already have rain because the and un are determiners. So just by applying those three filters, it was like a small afternoon of JavaScript. I was able to get these 10 n-grams down to 3, which sort of saved the day, and we were able to go forward with that. So given the success I had there, these are the existing tools. This is sort of the landscape of natural language processing as it is today. NLTK is the most popular one, probably. It's also like several gigabytes. You need to clear off room in your hard drive to use it. On the other ones, I'm not critical at all of these things. They're excellent. My favorite one is the Illinois tagger, not made in Chicago, but made at the campus down the road, whose name, Urbana-Champaign, I think it's called. Anyway, then you have these third-party ones, which sometimes are actually just wrappers for the most common libraries. There's, of course, a lot of value add with Embedly and Samantha and so forth, but it's a very big deal. And if you're at a hackathon or you have 2 weeks before your startup needs to launch, it's going to be tough to put this in your stack, right? Like these are very serious products to use. And what's worse is that a lot of them were made, in the 80s, or at least like have their history from the 80s. So if you want to get like XML out of them, good luck a lot of the time. So it's a different culture, and I'm not too critical, of course, but I think I found a place where it was actually useful. Because remember, in like the 3 lines of JavaScript I used, like the sort of hacky crowbar method, I was able to get my 10 n-grams down to 3. So I felt like it could be hacked. Like I didn't want to sit down and write my own natural language processing engine, but I started to, because we think of language as this gigantic thing. We spend most of our lives either reading, writing, speaking, or writing. But how big is it really? Like, can it be hacked? This image is the printout of Wikipedia. Currently, it's 5.1 million. But is that how big language is? Short answer is that the TLDR is that it's actually really small, and we're going to see that happening. So this is Zipf's law. This is George Zipf. He has a German name, but I think he was an American linguist in the 40s. What he did is he looked at all the words, all the languages in the world, and did a frequency analysis of the words, and found that they all fit exactly the same curve. Like, no matter if it's Arabic or German or English, they all, the top one would be the, in English, at least the most frequent word, and then you have like the sort of fall off words like chair and table, but then you have words that you'll hear once or twice in your life. So what happens that if we're actually using language, another thing I'll say about Zipf's law is that it actually also applies to characters in words too, in some sort of freakish coincidence. Like E is the most frequent letter or character in English, and then it falls off really quickly as well. People have looked at this in like whale songs and found Zipf's law, or like that Zipfian distribution there as well. Some people talk about the search for aliens, as in like how do you detect that a message is communication or a language and not some natural phenomena. People want to look for Zipf's law in that. Anyway, it's pretty interesting, but I won't go into it. The most important thing to know is that it's just a very steep curve. So if we draw our filter off at that point, we can actually cover 95% of English really quickly. Same thing for vocabulary. When you talk about how big a vocabulary is out of somebody, there's a lot of like this cheeky sort of attitude. It's like with IQ, how people talked about IQ as some sort of scientific measurement. Same thing goes for like vocabulary size too. Most people settle around this 30,000 mark. It's supposed to be like those lines that are going above are like if you go to Yale or something. But it's not that bad. If you take all of the works of Shakespeare and you split them up by words, it's of course a little bit more complicated because some terms are like multiple words, but so forth. It comes to around 30,000 mark as well. So it's not going to be double that, and it's not going to be half of that. If we give it a little space to 50,000 mark, just to make our math easy, that's actually still really small. If you print out, I did it, if you print out 50,000 words from Wordnet into a text file, and how big is it? That's 602 kilobytes. If you have a startup and you have a background image on your website that's full screen, that's like 2 or 3 megabytes, right? Like you're talking every word of English that you'll ever speak. If you had a little microphone on your ear from the time you were born to the time you die, like all of those words are smaller than like one image on a website. This is the distribution of words in Wordnet. If you don't know Wordnet, it's pretty great. It's basically the one interesting project in linguistics that everybody uses. It's like the benchmark. It's a dictionary, but what makes it interesting is that it's a dictionary split by sense. So the word hot would appear as like sexy, but it also appear as hot as in temperature. Also hot as in like electricity going through a wire, the wire is hot, so forth. It splits it out like that, and it does all those sort of tricky lumping and splitting that you're not going to want to do if you're doing a project using language. But anyway, this is the distribution of words in Wordnet. The main thing to know is that it's 70% nouns, right? Most of the natural language processing toolkits I looked at, in fact, all of them, when they're trying to recognize a word, they don't know, they didn't see it in their lexicon, they don't recognize it with any of their rules or tools, they always fall back to a noun. And that makes sense, you know. You imagine if I say the word lactobacillus, and you're not a biologist, you don't know what that is, but you're not thinking that you're going to lactobacillus to the store, so it's not a verb, and you're not thinking you're going to, that person is really lactobacillus. Most things are nouns. So if you just assume you're going to fall back to a noun, if you don't know what it is, you can chop out all of them and just fall back to the ones you don't know. So we've gone from 600 kilobytes to 180 kilobytes, and we're going to go even further. This is how words conjugate. Like we know if you know the word tomato, and you know the rules of English grammar, you also know the word tomatoes, and potentially tomato-y, if something has a lot of tomatoes, or if something becomes more like a tomato, you tomato-ize it. In software industry, we're pretty guilty of abusing this one, the quick and quickly, like fastly, and things like this. In sports journalism commentary, you have a lot of abuse of this aggressiveness issue. I'm not a grammar snob, but you see how words sneak in between different tenses, and it's usually just the suffix that changes, in English at least. So of course there's exceptions, but you see that verbs tend to move around, and so if you know one of them, you know all of them. And converting them, I'm not going to talk about verb conjugation, but you can imagine it's just a series of transformations. You know, if you have a really delicate number of regular expressions, you can cover most of them. So yeah, so we've gone from 600 kilobytes to 180. Now we're at 110 kilobytes. Remember, this is every word you're going to hear in your whole language, in your whole life, in 110 kilobytes. And if you are a web developer, you're going to know this graph. This is the file sizes of the most common libraries. They're growing as time goes on, of course. But remember how small 110 kilobytes uncompressed is. Like this is unheard of how small this is. It's crazy that we're not importing it on every website, almost. But you can see how I sort of fell into this, where I started believing in this being a thing we can actually do and use, and that would be a useful tool. Okay, so we talked about the lexicon. This is sort of the sequence of how I do part-of-speech tagging in NLP Compromise. The first one is lexicon. So we established a really big list of words, and if the word happens to be in that list, then we know the part of speech. And the second thing is suffix rules, which we talked about briefly. Like this is if the word ends in ly, for example, it's really likely to be an adverb, right? You have exceptions like fly or comply, but most of the words in English that end in ly are like quickly, immediately, and so forth. So if you have really careful regular expressions, you can actually identify words by their suffix as well. The third level that we'll talk about as well is sentence level, sort of Markov chain type deals, where if you have, no, I'm going to wait until that slide to talk about it. But anyway, these are the three sequences of how NLP Compromise does part-of-speech tagging. And we're able to get pretty accurate results from it. This is actual printout of the file. When I'm talking about a list of regular expressions, I'm not joking. It's quite brutal. I know there's cleaner and better ways to do this, but it works pretty well, and it's under a millisecond, and it's quite accurate as well. You can see we support like times and AM, PM, and stuff like that. So this is the sentence level rules. When we're talking about she could walk the walk, right? Walk in the first situation is a verb, and walk in the second situation is a noun. So this is where the sentence level processing comes in. Like, if we have the sequence verb, determiner, verb, we know that something's up. We know we've misinterpreted the sentence, right? When I'm talking and you're listening, and vice versa, we're doing that all the time in our head. Like, as we hear the words coming in, we make a little mistake somewhere, and then as we hear the next words, we change our assumptions. And that's just what I did. I listed out, you can get corpus from Wikipedia or anything, and just list out the number of times that you see the verb, determiner, verb situation, and they're very small. Anyway, I thought this was going to be a huge part of speech tagging with NLP Compromise. It really is it's become a very small part of the project. If you look at sort of all the routines that we run, if you import a novel or something into NLP Compromise, this method actually gets hit very few times, so that was surprising. So in short, to summarize, you can make an accurate part-of-speech tagger very easily. And that's not to discredit the hard work that's been done by the brilliant people over like careers and careers in this industry, but it's actually quite easy to get to mid 80% with accuracy. There's sometimes these conferences, where all the computational linguists will go and they will like fight tooth and nail about, somebody got 92.8% accuracy on this test and somebody got 93.1, and it's like the biggest difference. But remember that these terms, like you may read a sentence and interpret it one way, and I may read a sentence and interpret it another way. There's like some sort of subjective amount of accuracy. So I don't place a lot of value in these. There's more important things with accuracy than accuracy with using language in software. So we'll talk a little bit about them. But it is quite easy. And if you want to roll your own, you can do it in an afternoon. It's fine. So this is where I've gotten to with this project. It's quite interesting. I didn't know what I was doing when I started, but I found it. I get emails from people with @retailbank.com email addresses saying how useful it's been in their work. I'm also getting, job offers and things like this. I've since quit the job at the startup. I'm more or less doing this sort of work full time now, which is crazy to me because I really don't know what I'm doing. This is one example I thought was funny, where we would negate a sentence, like keep on rocking in the free world. Like, doesn't keep on rocking in the free world? Don't keep on, keep on rocking in the non-free world? Or what is it was really a joke. But you see on GitHub, I folded in 14 pull requests this weekend, people using stuff like this. I don't know what they're using it for, but it's quite fun. It just says, it's like a, maybe, I wasn't sure if I was going to say this, maybe I will. It's a bit of a comment on the industry of computational linguistics, how this doesn't exist already. There are so many people working in this stuff, and the culture is to work really hard and have a deadline and write an academic paper, and then your focus is not on having something playful for people to inspire them to use in their weekend project, right? It's just not what people are doing. So stuff like this gets a huge response, at least that's what I found. This is another example. So I've tried to make this stuff sort of extensible, like a plugin, like how jQuery did it. I made a really simple one. It was to convert something into the Valley Girl type of speaking, where you take everything after a copula, you add so it is a cool library. And we're trying to make stuff like this really easy. I don't know, this is a bit of a cheeky example. Someone made a Chewbacca one and stuff like that. But you can see how this stuff it's fun to do, and people like doing it. My favorite bot of all is the one that transforms newspaper headlines, and then every noun, it adds cyber in front of it. So cyber Putin banned the cyber nuclear weapons. Anyway, it's quite fun, and it's an industry, but it's also a useful tool, because language should be able to be manipulated like this. Another thing I've been working on is sort of search and replace, or matching, like a sort of regex-like match for language. So examples like this, where after every determiner you want to insert a word. It should be like a really quick syntax to be able to do that. Right now, if you want to do that, Just with characters, it's not so easy. And the most important slide of all in this talk is this one. And it's easy to get carried away when you have 85% accuracy or 86% accuracy. But the most important thing to remember is this slide. These are two sentences. We gave the monkeys the bananas because they were ripe. We gave the monkeys the bananas because they were hungry. One of the most trivial, or like supposedly trivial, things to do in NLP is called anaphor resolution, or pronoun resolution, where they, in the second sentence, refers to the monkeys because monkeys are hungry, or things that can be hungry. And they, in the first situation, refers to bananas because bananas are fruits, and fruits are things that can be ripe and so forth. So in order to interpret this, it's the very most simple thing you could possibly do in a sentence. Just figure out what the pronoun is. It's impossible until you know that all this knowledge, like monkeys are animals and animals are, marsupials, I don't know. But there's this level of knowledge that's necessary to fully understand a sentence. So if anyone tells you they're getting plus 95% accuracy in anything, like ask them where their knowledge base is, like when they invented the AI. I'm not sure they have yet. So usually when you try to understand a sentence, sort of going from the bottom up, we gave the monkeys the bananas as a string of characters. So this is usually how we work with language as computer programmers. We do like sort of state machine, regular expressions, so G, A, V, E, and so forth. I would encourage you, when you're working with language, to take a step up. I'm not sure if I've been too much of a master manipulator, but working with part-of-speech tags is much easier than working with characters, because you have all these different situations. One thing that we're working really hard on, the people involved in NLP Compromise, is contractions. Contractions are things like he isn't, or apostrophe S, or apostrophe NT, and so forth. You don't want to get caught up on stuff like that. If the user is typing in, they have a white box to type in stuff, they're going to type in a lot of crazy stuff, and you don't want to get caught up on stuff like that, and you don't want your developers to have to be writing, cases to handle this contraction, cases to handle that and contraction, stuff like that. Part-of-speech tagging, it's really useful. If you have a tool like this, it's just like a one method call, and you have these tags, and then you can handle them so forth. The next level, which is something I don't know anything about, but I find interesting, it's called dependency parsing. Sometimes you see, if you've taken a linguistics class, you see people write out like a branch, like a syntax tree, it's called, where like the word give here applies to noun. Like it applies to the monkeys. So we gave, and then everything after that is what they gave. It's hard to do. It's really hard to do. I haven't read enough about it to start doing it with NLP Compromise. I think I should. I think I'd like to try it at least. But the last level, of course, is what I talked about, the sort of knowledge engine strategy, where you know what a monkey is, you know what a banana is, you know that giving means like the voluntary transfer of property, blah, blah, blah. Like people used to call this level psych, or open psych, in the 80s. I used to call this level freebase, and both of those projects have sort of died in spectacular fashion. A lot of people are calling it Wikidata now, that level. I roll my eyes when people say that. So I don't know what that's going to look like. A lot of people are working on it, and a lot of smart people are working on it. Sometimes the solutions are too smart. So I don't know what that's going to look like, but that's, of course, the interesting one. So last slide. The things that we're working on right now. If you want to get involved, when people talk about GitHub projects as sort of the panacea of democracy, I've run into a lot of like mean maintainers of software projects. I always feel like my background is from Wikipedia, so I always feel like people should be able to do a lot of different things to GitHub. So I insist on being the most thoughtful and nice maintainer on GitHub. So please get involved. One thing that's being discussed right now is the immutable issue. A lot of people are talking about it in JavaScript, but if you want to change a verb to another tense, for example, and you want to chain that into another thing. So right now, every method returns this. except for some of them which don't return this. So it's a little bit tough. Some of the things we're talking about are doing like event machine sort of logging, so you can reverse it and time travel and stuff like that. There's some neat ideas that will mean a big API refactor. The other thing is speed and performance. Right now, NLP Compromise will understand a sentence in about 8 milliseconds on average, which doesn't sound like very much, but if you put a novel in, it may be like 20 seconds or something like that, which is fine for some situations, but definitely not all of them. I'm certain we can get that down to half with some caching or something like that. If you're interested in that, please contact me. The other thing too, of course, is splitting out to different languages. A lot of these really clever natural language processing engines are able to, like, from the get-go, do any language you want. You could put Klingon into it, and it will understand it. You know, we're definitely not there. I would like to start working on a similar rule-based small JavaScript library that conjugates verbs in Spanish, Portuguese, French, and so forth. One of the things, as another criticism of the computational linguistics field, it's really hard to get data. As a web developer, most people here, you know, if you want to try something strange and funky, you will find that 100 other people have tried it, and there's Stack Overflow and stuff like this. There's not a Stack Overflow for this field, and a lot of it means reading papers and emailing the people and saying, hey, can I use that data set? And you never get the data, right? It's just like not a culture of sharing. So, so the hard part of that bullet point is actually getting a good data set of verb conjugations to train on. The last thing, of course, is I've said before, I'm trying to make this the D3 of text. And one thing that was really helpful with D3.js is this sort of demo scene where it made it really easy to make something cool and share it around, and the code was there to copy and paste. So I'm trying to think of ways to do this. If anyone has a good idea, I'm thinking of using Tonic maybe, or something similar, where you can make some sort of cool example and share it. So that's that. I'm from Toronto. If you ever want to get a beer or a coffee, that's where we have a Slack group if you want to join it. I'm Spencer Mountain on Twitter. Thank you very much.
I think we have a few seconds for questions. Hey, Boodle, how's it going? Suze? You were first.
Yeah, so to repeat the question, which is a good one, is there not some sort of systematic bias in every interpretation? Is like a standard for grammatical parsing, like a moot point or impossible task? I think that's a good point. I recently got in some trouble with, no, maybe I won't.
Don't do it.
Sorry, excuse me.
It's interesting. I think it's an awesome discussion.
Okay, yeah, no, that's a very good point, and it's fair, and it would be a criticism of the entire natural language industry. Yeah.
Oh, sorry, yeah.
Exactly, yeah. To repeat the question, or the comment, is the interpretation of meaning, like, no matter how complicated it is, whether it's like a metaphor or anything, can that be handled with a rule-based system as well? Yes, I think so. In fact, I've worked on a lot of things I'm not allowed to talk about that are very similar. It's something that you'll want to do, like, statistically, right? Where, say, so in Britain, if you say hammered, or what is it, smashed, one of them means tired. Hammered means tired in Britain. Hammered means drunk in America. So there's going to be things like that, and also, you know, like class and stuff like that. So there's a lot involved in how someone interprets things. So you need to know a lot about them. But it's like a statistical thing, you know. 9 times out of 10, hammered means smashed or drunk, whatever. So it's a very interesting problem. I encourage you to work on it.
Cool. Thank you very much, Spencer.